Okay, here comes really the main, to me, the main concept, or it's kind of the fun part of the course for me, because everything was leading up to this chapter 6, which now we're going to end up first taking a look at something called the binomial. It says 2. You guys learned that from algebra, two things. For us, it's binomial distribution. It's a probability concept. And then the rest of the course is going to be on what's called the normal, which will be the bell-shaped curve. So we're getting to the bell-shaped curve, and the bell-shaped curve won't be until Wednesday. So today I want to set up and you'll hear some familiar words like discrete, continuous again, that'll come back up again. And what is a valid probability distribution, which if you think about the relative frequency table, you can never have negative relative frequencies or negative probabilities. That's impossible. And that column for the relative frequency all have to add up to the number 1. So it's kind of a reminder, but we're going to call it a probability distribution instead of a relative frequency table. And then 6.2, that's where the binomial, the two things occur. There are other, I'll call them distributions other than the normal, that's the bell-shaped curve. There are other distributions that your author goes over. 2 of them, I'm not holding you responsible for those. And then there are other ones out there that if you're into a major / work environment that requires, or you'll need to know about these other distributions, either your work environment might guide you, or you'll have to learn it, or maybe you're going to take a master's degree and you'll definitely need more statistics. But for us, there's only 2 distributions. One's the binomial and the other one's a normal that I'm going to teach you, and you're responsible for. So, discrete, continuous. We've done that before. There's nothing different, nothing new. Except binomial, and this one here is normal. So now I'm going to give you words where this is 6.2. The binomial is going to be discrete, and the normal is 6.3 and beyond. And beyond. Sounds like Buzz Lightyear. To infinity and beyond. But today it's 6.1 and then 6.2. That's all you're going to do. Most of the tables, just like this table here, in our author's the textbook, will go this way. Now, if I turned it this way, it feels backwards. If I flip that, here would be your X back in chapter 2. Relative frequency would be on the right-hand side. So it would be an X here and relative frequency here. You did that already. You were tested on that. So instead of relative frequency, we call it P of X, and we're going to do it this way. So you guys know about the random variable X. Usually you give it a title, like in algebra, you give it a title. For us, we've done that before in chapter 5, first part of chapter 5. P of X, capital P for probability. And if you want to say instead of X, you might want to go E, like E is the event, and P of E is the probability of that event. And we fill out the the chart up here, I usually start off with what goes up here. I've given you 4 spots. Maybe we only use 3. We'll see. Number of tails, let's see. And you're flipping the coin 3 times. So you could have, gosh, you could have all 3 tails. Right tail, you can have that. Could you have exactly 2 tails out of the 3 coins? Exactly 1 tail out of the 3 coins? No tails, that would be 0. Yeah, you can have 0 tails. So these are digits. You don't write the words, you put in digits. 0, 1 tail, 2 tail, 3 tails. And the probability of getting the tails, going back to chapter 5.1, you can make up a sample space and then count. Might as well do that right now. It's a good reminder how to do that. So capital S is equal to sample space. Head, head, head. Tail, tail, tail. Head, head, tail. Head, tail, head. Tail, head, head. Head, tail, tail. Tail, head, tail. And tail, tail, head. I think I've got all of them mixed, and there's no duplicates. So how many of these is no heads? Just that one. So it's 1 out of all of it, the entire sample space. So it's the count of the event divided by the count of the sample space. Remind you, it's all in the back. 5.1, 5.1. I think it was 5.1. It was under the classical method that says, okay, so if I do sample space here, the event is even. You count the evens, 2 and 2, 3. 3 out of 1, 2, 3, 4, 5, 6. 3 out of 6, and then reduce it. So yeah, you've done it. So this is out of 8. Okay, count how many exact 1 tail. Exactly 1 tail. 1 tail. 1 tail. 1 tail. Okay, there's 1, and there's 2. There's 3. Okay, that's 3 out of 8. Exactly 2 tails. 2 tails. Okay, 1, 2, 3 again. And exactly all 3 tails, which is just 1. And if you add up all the probabilities, it must add up to 1. Otherwise, what they say, it's not a valid probability distribution. You're going to get some homework problems that will say, is it valid or not? Is it valid or not? And all you're doing is saying, I wonder if it doesn't add up to 1 because then it's not valid. I wonder if there's negative probabilities because that's not valid. I wonder if there's a probability that's beyond 100%. That's not valid. So right now that's valid. See, all the probabilities have to add up to 1. Each one has to be between 0 and 100%, and so on. Okay, so let's say insurance company has, well, there's lots of insurances you could buy. Most all of you, if you drive, not everybody drives, but if you drive a vehicle, you are legally bound by the state of California to have auto insurance, at least liability insurance. You must have that. If not, you're driving illegally. They stop you. They'll impound your car. I don't know, maybe they'll haul you off to jail. I don't know. So insurance companies sell auto insurance and health insurance and life insurance and renter's insurance and home. So you got an insurance company, in this case, we're going to have, that's like death. That's like, they call it life insurance, but it's really death insurance. And you're paying, some of you are saying, what is it talking about? You might have someone you know that talk about life insurance. It's insurance that you don't get. If it's on you, you don't get, somebody else gets it upon your death. That's why they call it death insurance. And then disability is more for you if you get disabled and you get hurt, so that you can have some income other than just Social Security or disability insurance. So let's say you offer, this company says you can have a policy and it's going to pay $10,000 if you die and $5,000, not monthly, but pays you a lump sum if you're permanently disabled. The premium, if you have auto insurance, you know what that means, unless your mom and dad pay for it. It's called a premium. Sometimes it's monthly, sometimes it's annual. This one here, it's annual. So it's going to cost you $50 for the year to have what they call the benefit of these two pieces right here. So this simple example, the company says, if the company insures exactly 1,000 people for that year, and in that year, one person dies and 2 people get hurt, and they want you to, well, I want you to fill out this table to make it a valid probability distribution. So we're going to let X be the payout in money, the payout in money. So what could the company pay out? They could pay out $10,000. They could pay out $5,000. Or they can pay out nothing. Like some people don't have an, they call it a claim. Some people aren't making a claim against their policy. So they could pay nothing. This is the company. The company could pay nothing. They could pay 5,000, 10,000. Turns out, because the relative frequency says one person, so they had to pay one person or one person's family, one out of, okay, and how many people did they insure? 1,000. That's the sample space, is 1,000. Okay, so that's the life insurance or death insurance. This one's the disability, and it says 2 people became disabled, so it's 2 out of 1,000. And how you go about finding this, it's just called the leftover. And we've done that before. It's called the complement. That's another way of looking at it. It's the leftover is the complement. So to make up 1, that's the other way of doing it too. I want to make this up so that you add up this to be 1. I'm missing 997. So that the numerators all add up to 1,000. So you'll be asked to fill in a chart based on a problem in your homework. And that's just one idea, one example. We'll come back to this, by the way, in about a couple pages. Come back to the same problem. Okay, another problem. Got a soccer player, likes to score goals. The probability or the chance that he's going to score no goals, 1 goal, exactly 2, or exactly 3 goals in a soccer game turns out to be the following probabilities. Now, how you might have gotten these would have been, well, the past 2 seasons, let's say the past 2 seasons, they've recorded the data. And then they found out over the past 2 seasons, he's 25% of the time, he doesn't score any goals. 35% of the time, he scores exactly one. You can't score a goal and a half. You can't do that in a game. And 2 or 3. Doesn't look like he's ever scored more than 3 goals. And it doesn't make any sense to score negative goals. That's dumb. Here it says construct the distribution. And that's what you're going to do right here. So X, you'd say X equals number of goals. So number of goals scored, X here. Okay, you could score no goals. I mean, the numbers are up here for you. 1 goal, 2 goals, 3 goals. And it turns out they give you the probabilities. These are the probabilities. You didn't have to figure it out like the last problem. So probability that he scores no goals would have been, and these are in order of the, because if they weren't, they would have told you. 0.25 and so on. And to make sure that it's valid, there's no negatives, that's a good thing. I want to make sure that you add all this up and it adds up to 1. 0.25, 0.35, that's 0.6. Add another 0.85 total. Yeah, that's going to be 1. So thumbs up on that one. All right, now there's a few questions right here. First question is this one. What's the probability that Buster will score? All right, now this one here has the word fewer. We're back to your understanding of the word fewer, whether it's one of these symbols, this one, this one, this one, this one, or that one. You got to pick the right symbol. If you're not sure, you go in the back of the packet. Okay, fewer would be this one here, or less than. So what's the probability that scores fewer than 3 goals tonight? Well, that would be here. 2 is fewer, 1 is fewer, none is fewer. What you're going to do is add up the probabilities. Here's another way of doing it. Probability that X is fewer than 3. So you'll have 0.25 plus 0.35 plus 0.25 equals 0.25. Next question says, what's the likely, okay, now most likely number of goals? Now, when it says most likely, what you're doing is you're looking at the highest probability. What's he likely to score based on past results? He's got a 35% chance versus the other ones. Most likely he's going to score 1 goal, exactly 1 goal, most likely, if you're going to put money down on it. So most likely, and the final one, it says the word at least. We've seen the word at least dozens of times. Probability that he scores at least, that's greater than or equal to 1. And so again, you're looking at least 1. So you count the 1, count the 2, count the 3. At least means more than or equal to 1. So 2 is more, 3 is more. So add up your probabilities right here. So you got 0.35. Looks like it's 0.75 or 75%.
I'm sorry, Jeff, I'm still not understanding. So will we always be we'll always be given the probability in the question, like the probability of X. So it says like 20.25. So 25%, 35%, 25%, 15%. Like it says it right here.
Yep.
But will we?
Did it say it over here?
No.
No. So sometimes you got to figure it out. Sometimes in your book, same thing. Sometimes they'll give it to you. Sometimes they don't. Sometimes they do. Sometimes if you're a researcher, you've got to go out and gather data and look at the results and break it down based on what you've recorded, called relative frequency. So let's say you were the person that watched Buster's. You were like a recruiter, or the coach hired you or had you come in as the stats keeper. And over the past 2 years, you collected all the data and found out that, oh, I don't know, let's say make it out of 100. 100 goals scored over 2 seasons. There were 15 3 goals scored. There were 15 occurrences out of 100 games that 3 goals. So
Were scored.
15 3 goal nights. There were 25 days. Well, not days. 2 goal nights. Well, that's even. There were 25 2 goals. Sounds like I'm really confusing you. You're gathering the data. So you're looking at your results and you say, hey, there must have been and they only had numbers from 0, 1, 2, and 3. Mm-hmm. There were 15 threes out of 100. That's 15%. And there were 35 ones out of 100. That's 35 divided by 100 is 0.35. So you're recording the data. So in the homework, sometimes you get problems like this. You got to figure it out. What did I do? Sample space. 1,000 people, 2 people out of 1,000, 1 person out of 1,000, and the leftover is the complement. Versus, there'll be some homework problems. They just literally give it to you. Literally.
Okay.
I think you might be complicating things, Spencer.
Probably. The probability is high.
Number 17 is just like the Buster soccer. They give it to you. Number 18, same thing.
Okay.
Number 19, they give it to you. They just give it to you in words. 1/3. Well, shoot, that's 1 out of 3. 20, they give it to you. It's there. So let's see what else they got here. 62, they just put it out. Oops, here, or 62. They just put it out for you. They actually make the table up for you. You don't even have to figure it out. 64, same thing. They give you a table. So I think I'm answering the question for you.
Yeah. I'm also, what I'm more concerned about is like, I'm not understanding how exactly the formula to find it. I'm not, like, I was curious because like if they don't give us that, how do we know what, like in the chart, what it's going to be, and then the work that it takes to find it?
I didn't know how to fill that out.
Okay.
Someone's got to tell you, or you're going to have to come up with a scenario. Hey, I'm going to flip 3 coins. Hey, I'm going to have 3 kids. I'm going to have 3 kids. And I'm going to say, let X be the number of boys. So how many boys could I have? I could have no boys, 1 boy, 2 boys, exactly 3 boys. So you have that information that you have to kind of figure out. And then what I did, or I highly suggest that you come up with a sample space. That's what we did back in earlier chapters, how to develop sample spaces.
Mm-hmm.
And then all I'm doing is counting from the sample space.
So you literally just make a sample space and then you can.
That's what
Yeah,
I
rest of your work.
highly suggest. Yeah.
Okay. Alrighty. Thank you.
Yeah.
Jeff, I have a question.
I'm not sure who's asking, but yes, go ahead.
Me, Annie Ellie. So I got a little lost with all the back and forth. How do we come up with what is the most likely number of goals Buster will score?
Oh, most likely. Likely. Oh, that looks weird. I'm the world's worst speller. That looks weird. I think it's that. I think most likely.
Yeah, it's that one.
You have 4 choices of probabilities. What's the biggest one?
Oh, I get it now. 3.5.
Yeah. So the most likely number of goals is 1. So when I say the most likely is the largest probability, I'm not saying the answer is 0.35.
Yeah.
The word most likely is you're going to respond to what X is, but you're going to look for the highest probability. So maybe that's what I should say. Look for the highest. Yeah, look for the highest. That's better.
Okay, thank you.
For author, again, your author likely will put it in there somewhere. I'm just skimming for you. stick around after class. I'll find it. I'm just skimming, and it's not like big bold words in 6.1. I'm just giving you my definition.
Yeah, thank you.
And I know that there's going to be a couple questions that we'll use. Hey, what's the most likely result? It's just the largest probability answer. But stick around after class and I'll help you find it if in fact the author addresses it in his writings.
Okay, thank you.
Okay, you'll get some problems that says, is it valid or not? And you'll say, I don't know. Let's see. Let's add this up. 0.350. Okay, 0.85. That's 0.9. That's not. No, I'm going to say no, because the sum of all the probabilities is not equal to exactly 1. And if you add these up, the sum equals 1.05. So not valid. Is it valid? No. And this one's a no, because can't have negative probabilities. So you can't have negative probability. Say we wanted to know what the average number of goals Buster will score on average. Now, if I asked all of you what your age is to the nearest year, what your age was, what your age is to the nearest year, do you think I'm going to get exactly a nice whole number if I add all your ages up and divide by, what do I got here, 27 of you? I could, but likely not. So if I said, well, the average age is, 22 and a half. Well, I mean, you could say a person could be a half a year old. I mean, what about the average number of kids in families in the United States? I don't know if you've ever heard of this before. There's per family, it's 2.3 kids on average. How can you have a 0.3 of a kid, you might say? No, but it's on average, not going to be. You have some families have more than 2, some families have less than 3. So for you, for Buster, the average number may not be an actual nice, here's how many goals. It could be some portion of that. And how you figure it out with the probability distribution is this formula right here. And so you know what summation means. That means you got to add up whatever the product of X and its probability is. So here's your X and here's its probability. So you're going to take the product of each one of these and then add them up. You're going to take the product of 0 times 0.25 and add along the way 1 times 0.35, add, and 2 times 0.25, add, and 3 times 0.15. And then you get a result. So if I haven't committed a careless mistake, 1.3 goals. So on average, Buster will score, well, 1.3 goals, more than one goal. Not quite two, 1.3. It's called the mean. Of course, you know what the mean means, on average. And here's your formula. Oh, back to the insurance problem. All right, I'm going to fill in the blanks again that we had before. There was 10,000 here, 5,000, no money. So same problem. On average, what would the company pay out? On average, what would the company, the insurance company, have to pay out? They call it expected value or expected payout. Expected value is the same thing as expectation, expectation. And here's a symbol that I don't know if I've created it. Author might have it too. It's in the back of your packet. There's a definition for that. It's called expected value. And how you find it is the same way that we just did it on the previous page. So let's see. We would expect the company would pay out well, that's just zero. All right, plus zero. That's just zero. This is money, by the way. 20 bucks. Now, here's a clarification. It's $20 per or for every policy. That's just not 20 bucks altogether. Because look at what they paid out. They paid out actually, was it one $10,000 policy and they paid out $20,000 for the year, not 20 bucks. But how many people did they insure altogether?
1,000.
Well, what's 20 times 1,000? $20,000. See, I'm telling you, they paid out 10,000 and two 5,000s. That's 20,000. How do you create that? $20 for every 1,000 persons on average. Now, how much money revenue did the company bring in? If you're in business, you need to make sure your revenue is more than your costs. And then you've got a profit. You think the insurance company are in business to lose money? Like big banks? No. No. So you think they're going to make a profit. So revenue must be bigger than costs, or in this case, how much money did they just bring in? Well, $50. Every person pays $50 for the year, no matter whether they cash in or not. Well, that's $50,000. How much did they pay out over the year? $20,000. So they actually made $30,000, or $30 for every person. Every person pays 50, they pay it out 20. That's what they could expect to do, is on every person on average, they're going to pay out $20, but they're going to make $30 for every person. So yeah, they're making a profit according to this problem. So what would the average expected payout for the company? $20 per person. Or $20,000 altogether. So now you've learned that mu is the average, the mean, population mean, is expected value, means the same thing. And then there's this thing, usually you've got the mean and you got a standard deviation, you got a variance. Mean, standard deviation, variance. How do you find the variance? Because it's not in your calculator. You square the standard deviation. Standard deviations in your calculator if you have the raw data. So like sometimes you don't have the raw data, sometimes in this you're given information that you have to plug in. And I'm going to show you how to calculate this without your calculator, because I don't have a way of, I'm not going to give you a way of using your calculator to find it. This is one of those that you have to do it by hand. And it's not hard, it's just messy. Okay, well, what's the formula say? Well, it says I'm going to add up some stuff. I got a little product thing going on. And I got the difference of a couple things and it being squared. So there's a lot going on. Your algebra class says, or said, order of operations is important. PEMDAS. You guys learn that I'm surprised at how many years I've been alive for a long time. When I was in elementary school, I saw that. I wonder how much further back. I haven't talked to if my grandparents still alive, I'd probably ask. Probably been gone back for. Some people say, please excuse my dear Aunt Sally. I'm surprised how many your age millennials have heard that. They're still using that phrase. So you do parentheses first. You got to do parentheses first. So I got to do this first. And after that, you do the exponent. You do the exponent second. And then you do the multiply. And at the end, you do the add. So the summation comes at the end. Now, what you could do is do a table. I've seen some students do that, and that kind of makes sense. So maybe you have your X, and then you've got your X minus mu. That means we've got to figure out what the average is. X minus mu. And then maybe you'll have the X minus mu squared. Remember, you got to do X minus mu and then X minus mu squared. And then what's the next thing we do? You take that and go X minus mu squared times its probability. And when you're done, you're going to add up. You're going to add up this column, and that's your summation notation. Add up the column, and at the end, that's the answer. So if I put my X's down here, which I think my X's were 10,000, I want the insurance problem again. 5,000. Oh, this is per policy, so my mistake. Yeah, because I'm looking at mu being $20. So it's per policy. So my mistake. I apologize. So better go back over here. So mu is equal to, you know, here's a different way of doing it. If I keep it at the 10,000, I'm okay with this. If I keep it at the 10,000 and the 5,000, the mu has to be total average, which would be, what is that, 20,000? This is $20 per person. When I looked at this, this is 10,000, I'll keep it 10,000. That's all together. So you'd have to multiply this by 1,000 to give me my 20,000. Oh boy, can I squeeze this in here? 10,000 minus 20,000. $5,000 minus 20,000. And then this one was 0. 0 minus 20,000.
You're saying 20,000, but you're writing, there we go.
Thank you. Thank you. So I can do this in my head. That's negative 20,000 squared, excuse me, negative 10,000 squared, negative 10,000 squared. 5 minus 20, 5,000 minus 20,000 is negative 15,000 squared. Now this is a big number, and then there's your P of X. So P of X comes from your table. Remember the table? Yes, you do. It's right over here. See, there's P of X, P of X, P of X. So I've got to take this number Now, don't forget, all of this is underneath the radical. I'd still have to take the square root of it at the end. So what I'm going to do is I'm actually going to start with the square root in my calculator. So I can do it all at the same time. I'm starting with the square root in my calculator. And now I'm going to type this in the way I see it, but adding along the way. So parentheses, negative. Well, when you square a negative, you can see they're all going to be positive, so that's not an issue. I'll leave it as negative, but I'm going to put the power of 2 on it. 10,000. And then times, parentheses. Now, I have a capability in my calculator. Not all of your calculators can do this. Your TI-83, it's impossible. You can't do it. But the TI-84, only if you have the upgraded operating system can I go alpha. Otherwise, the rest of you are going to have to do parentheses, numerator / denominator. You'd have to make it look like a fraction, like this. 1, shoot, yeah, that's right, divided by, I mean, that's just what you would do. That's fine. It's not a problem. So what I'm saying is on the next one is if I go plus parentheses, negative 15,000 squared. And then times parentheses. Okay, now a few of you will have the capability to press alpha. Hello, press alpha. Let's see if that'll, that's not right. Okay, let's get out of this. I was just going to do it, but some of you are going to say, well, what did you do? What did you do? How'd you do that? Okay, so come on, Jeff, press alpha. Huh. It's not letting me change it. Okay, for some reason, forget it. I'm not even going to show you. Fine. Okay, 2 divided by 1,000. Oh, that's a Z. What the heck is that? Oh my gosh. Yeah, better. Okay, and the last one here is plus. I'm not going to be surprised if I hit enter and it's an error. I messed up somewhere. I'm not going to be surprised, and then I'll have to go find it. Okay, I'm going to press enter and see what I get. So that's the standard deviation for the entire total. That's dollars, so $19,983.74. Now, what does that number have to do with anything? Nothing. It's just a number. I'm really not going to use standard deviation until I get to 6.3. That's where it's going to be, I'll say, used a lot, important. But right now, it's just a number. And then you'll say, Jeff, in my textbook, is it found there? And I say, yes, it is. Standard deviation. There it is. So the textbook probably goes through, it does a calculation for you. On page 320. I'm not going to do this one. It's just doing another example, but you're, oh, look at this. I even said, hey, your textbook. What did I say, page 320? Well, there you go. That's the problem. Page 319, 320. That's the problem right there. So you can see how they do that on your own. Okay. Again, it's just formulas. This game I'm not going to do. I'm not going to do. Don't have time. And even the fun card games, if I were face to face, I'd do it in class. But the question is, would you even play the game? And you don't want to play a game if you're going to lose all the time, unless you're playing for fun and it doesn't matter to you if it's going to cost you. So how you decide is using what's called expectation or expected value to decide if you want to play or not. And for you, you want to play if the number is positive, because that's money. And if the number is negative, you don't want to play because that means you're going to lose every time, on average. And in If there was a number 0 that comes up, then it's up to you because that's called a break even. If the expected value is 0, then nobody wins, nobody loses, everybody just gets along. And so, shoot, in economics, there's something called the break even point. If you've had an economics course, or if you will, you'll hear it's called break even point. It's where the lines meet. It's where supply equals demand and everybody's happy. So there's a relationship, at least in the math class and a course like economics. I'm not going to do these, and you won't get something like this on the test. Okay, that leads me to 6.2. And this is where the binomial comes into play. Binomial is discrete, like I said before. The word bi implies there's two possible outcomes. There's some characteristics of the binomial, just like there is for the normal. There's two possibilities. Like you get ahead or you don't get ahead. Sounds like the complement. You roll the die. Okay, fine. You get an even number or you don't get an even number. So that's how, I think everything can be put into a binomial because you either get that or you don't get that. You don't have to say false. You can say true or not true. That works. New symbols maybe. Little p, lowercase p, is called probability of success. And the complement, this is called the complement. Is 1 minus p, or q is the complement of p. And if you add p and q together, it's got to give you 1. Oh, a tree diagram I've got for you to remind you. Let's say you're going to roll a die. You're interested in rolling a 6, so that's called success. Getting a 6 is a success. Not a 6 is a failure. So success is rolling a 6, failure is all the other numbers. Probability of getting a 6, of course, is 1 out of 6. The probability of not getting a 6 is all the left. It's 5 out of 6. Let's say you're going to roll the dice twice. Okay, fine. Tree diagram. So if you look at this, you'll say, well, okay, so you get a 6 or you don't get a 6. Second roll. You get a 6 or don't get a 6. Same down here. What are the outcomes? Well, you can get a 6 and you can get a 6. Okay, so what I'm doing in little squigglies is the sample space. So it's all the outcomes. I have 1, 2, 3, 4 outcomes. So 6, 6, 6, not 6. Okay, not 6 for the first one, 6 on the next one. And not 6, not 6. All right, now define the probabilities. I'm going to stick in red. I'm going to stick probabilities above the number or below the number. In rolling a die, the probability of getting a 6 is 1 out of 6. What's the probability of not getting a 6? Well, I can put it up here. 5 out of 6. That's not getting a 6. So all the 6s are getting the probability of 1 out of 6. All the not 6s is the probability of failure, which is 5 out of 6. So this is 1 out of 6. This is 5 out of 6. 1 out of 6, 5 out of 6. So the probability of the outcomes, in order to get a 6 and a 6 the second time, exactly that, to get a 6 and a 6 the second time, you multiply your probabilities along the pathway. That's how you'll end up doing it. So what I'm claiming is your probability of getting a 6 and a 6 would be 1 out of 36. That's the probability. In like manner here, you'd have 1 out of 6 times 5 out of 6. And if you add all the probabilities up, it better give you 36 out of 6. 36 out of 36, which it does. So what's the probability of getting exactly 1/6 in the 2 rolls? Exactly 1/6 in 2 rolls. Wouldn't that be this one here? No. So the probability of getting exactly 1/6 in 2 rolls would be the sum of these two right here. Today we're going to be looking at, I think in the next couple pages, we'll be looking at using your technology, because this is called a binomial distribution. And your technology, there's some special keys that you could bypass some of the calculations. It'll give you the result. So I'll show you that here coming up in the next page or two. Well, here's a big formula. Yeah. Okay, you see this right here? You've seen that, your homework, your last homework you did over the weekend. So if I'm looking at, this is multiplication, by the way, in between the parentheses and the P. This is multiplication right here. Multiplication right there. Same idea here. So if you can start off by figuring out, first of all, it's a combination when it gets to the binomial, not a permutation, it's combination. If you can figure out what the total number of trials is, what the total number is, and then what your specific number you're looking at, which is a subset, then you're just, for the powers, you're just following the numbers for each one of these. The P is the probability of success, which they either give it to you or you can figure it out. And then the difference right here is what they call Q, which is the complement. So if I gave you 1/4 for success, you'd say, well, that's 3/4 altogether. 1/4 for success, 3/4 for failure. And the result of this is, instead of trying to do all this stuff by hand, instead of trying to do all of this with a tree diagram, I mean, which it gets a little confusing, if you can create, like this with the previous problem right here, if you can create the formula, make sure you get all the values right, then you can use your calculator to help you get to the same answer instead of a tree diagram. So probability of getting exactly 1/6 in 2 rolls. You know you have 2 rolls. N is, okay, this is the number of rolls, number of trials, 2 rolls. x equals only 1, 6. Probability of getting to 6 is 1 out of 6. Probability of not getting to 6 is 5 out of 6. So if I'm going to use the formula that's up here, you'll say something like P of x equals 1/6. Shorthand, like I did right here, but shorthand. And here comes the formula. Okay, so n is 2, right here. Choose x is 1 times probability of success is 1 out of 6 squared. Excuse me, raised to the 1 power. I apologize. Follow the formula, Jeff. See, these x's are the same. So this has to be a 1. And this is the difference. So it'll be 1 minus 1 out of 6, which is 5 out of 36. Of course, you'd write that. You could say 5 out of 36 instead of this value. And then you do n minus x. So 2 minus 1. 2 minus 1. And when you're done, you should have your same answer as I had before, which we're going to check. So 2, choose 1, 1 out of 6. 5 out of 6. And remind you where you find that combination right here. It's in the probability, the math. Probability. Shoot, Jeff, didn't you say you had to put the n in first? Yeah, no. So I have to start all over again. I have to put the 2 in first and then find that. So put the 2 in first. Now that I know where it is, there it is. And then you put in 1. Now I'm a little gun shy if I went times or parentheses 1 out of 6. It might take that number 1 and do that. I'm going to hit enter first. I'm going to figure out what that value is first. It's the number 2. So this right here is 2 and then parentheses 1 out of 6 and then 5 out of 6. And, well, multiply straight across. This is easy baby fraction for you guys. That's 10 out of 36. 5 out of 18. Is that the same fraction as the previous page? I think this is hard and this is messy. And I don't think you're going to end up doing that often. Although the tree diagram is nice to be reminded about. This seems like it's a little easier. You just got to understand the formula because you get the same answer. And then the other calculator way, which is even easier than this, would be to do that. And what I'm showing you only works if it's what's called exact. If you ever, and you will, have the phrases at least, no more than, fewer, at most, you can't use PDF. You can't just use it immediately. I'll have to show you how to work that out as well. So here's what you'll do. I'm still going to look to see if I get the same answer I'm supposed to. Here's what you do. Second. Now there's a distribution key right here, vars. It's hard to see. Right there. Second distribution. Who doesn't have that on the calculator right now? I'll do that over again. Because it's right here, second distribution. That's what I'm doing. And who doesn't have the screen? Okay, now I'm looking for binomial PDF. Not there, not there, no, no. So go down here. Keep going, keep going, keep going, keep going, keep going, keep going. Keep going. There it is. Now, if you have a TI-80, and the 83 works just the same way. You have T83, it asks for something different. As a matter of fact, it puts parentheses in. Anybody have an 83 right now? Speak up. Who has an 83?
I do.
Okay, so yours, Dasha, will have, instead of listing here, you'll have a binom PDF and a parentheses.
Yes.
So then what you're going to do is follow here. You're going to put in the N, put commas, P, put a comma,
Okay.
put an X, and hit enter, and then wait. And we'll compare my answers. The rest of you, trials is N. So my N turns out to be 2. Toggle down. Your p-value is 1 out of 6. Your X value for us is 1. Go down and hit the paste. Now yours will look like Dasha's. See, Dasha had this things that she had to put in first. And yours turns out to be at the end, but you didn't know that because you got an 84. Press enter though, and then you get some weird decimal. By the way, if I asked you to round this to the nearest hundredth, 2 decimal places, it would be 0.28. If it says 4 decimal places for your multiple choice, because you see 4 decimal places, so then you go 1, 2, 3, 4. Okay, it's going to be 0.2778. You got to know your rounding. And if you're struggling with that, see me outside of class. Okay, now, my 80, and Dasha, I think you have capability of doing this too. So if all of you went for, math button right here, you see the very first one, Dasha, do you have a frac, the word frac on theirs?
Yes.
Okay, so hit enter, all of you hit enter. You still had to have had the 0.2277 up to begin with, because it's going to take that decimal and frac it, meaning it's going to give you the fraction. If you erased it, it's not going to do it. But if your last statement was this weird decimal, like 0.5. Okay, 0.5, you know it's a half. If I go math, frac, the previous answer, which is a half, should give me 1 over, excuse me, 1 over 2. Most of your answers are going to be decimal, though. It's not going to be fractions. Rounded most of the time 4 decimal places. Or 2.
Jeff, could you go over again the N? The N was 2, the P was 1/6, and what was the X? When we
you're
were
only
putting it in the calculator.
See, it's like here. See how X equals?
Yes.
X equals, X equals, because it's
Okay.
formula.
6.
Usually they're going to have in your problems what your X is. You'll see with a couple more problems I have coming up. The big thing is what's the N, and N is always bigger than or equal to, bigger than, N is never less than X, never. This can't be smaller than that. So I'll show you something over here.
Does that even count on the previous chapter on 5.2 and 5.4?
Yes, it
Can
does.
count. Okay.
Yeah.
Thanks.
Yep. X can never be bigger than N. They can be the same, but they
Like
can't.
that one that was 100 and 100.
Right. N choose 100. Yeah. Well,
My calculator came up with error on that one.
right. NP 100 is even worse.
Yeah.
You see blah, 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 random sample. Aha, random sample. There's your N. You know, lowercase n, sample size, random sample. That's N is 36. And down here, 2. That's X is 2. The word no means the number 0. Oh, X is 34. Looking at the wording here. Oh, I'm going to take a four question multiple choice quiz. Okay. You didn't study, blah, 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 blah. Okay. 5 choices. Okay. Well, a little bit more work. But if I look at a scene, doesn't that mean he's going to get them all right? So you have to say, well, how many questions are there? 4. So N is 4. X is 4. A scene is 4. X is 1. X is 2. N is still 4. Still 4 questions. What's the probability of guessing right on this one? Well, only one answer, like your multiple choice test, there's only one right answer. So how many possible answers? Oh, there's 5 choices, A, B, C, D, and E. So 1 out of 5 is your chance of guessing correctly. 4 out of 5 is not guessing correctly, guessing wrong. Flip a coin 3 times. How many times? 3. N is 3. Flip a coin 3 times. Oh, okay. All heads. What do you think X is? These are all your X's here. What do you think all heads means? X, what's the number for X? All heads.
3.
Right, so X is 3, N is 3. Oh, okay. X is 1, X is 2, X is 2. But look at the phrases that we have to deal with. More than, at least. So I'm going to do, because of time here, I'm going to do one of these. I'll do this one. Okay, so X or N equals 3. Okay, when you flip a coin, isn't it 1/2? The probability of getting ahead is 1/2. Yeah. So the probability of little p equals 1/2. Getting ahead. So letter A. All heads. So that's 3. Okay. Now, if you did the formula, which you don't need to do the formula, by the way, if you did the formula N choose X, it would be 3 choose 3. But binom, B-I-N-O-M, PDF is, well, it's right over here. It's NPX in that order. NPX. It's NPX. And then what you do is your calculator, go back to binomial, so that's second distribution. Got to find that binom. Oh, there it is. Not the CDF, be PDF. Okay, so trials is N, so I've got 3. So this is NPX. Okay, P is right here, 1/2. and X is 3. By the way, it happens to be 1/8. If you did this by, hey, let's create a sample space and just count, you would get 1 out of 8. Think about it. Head, head, head. There's only one of those out of a whole sample size of 8. 1 out of 8. Part B. Probability. You get X is equal to 1. So same thing, binom PDF. That's 3, comma, half, comma, 1. Letter C comes the harder one, probability. And this is where if you don't have your phrases and your inequalities down, you're not going to get it right. The at least is X is greater than or equal to 2. Okay, now this is the way that you work it out with the PDFs. You have to, because you have to start out, you have to do them in separate little PDFs. You go P X equals 2 because you start with 2, plus now bigger than 2 is 3. Can you be any more than 3 with flipping 3 coins? Can you get any more than 3 heads? No, and then, so you stop there. So then you do binom P D F N P X, X is 2, and then you go plus, and do it again, binom P D F 3, 1/2, and 3. So you have to do them separately to get the result. You have to do them the way I'm teaching you. Second. Does the phrase no more than include the equal sign? Does the phrase no more than include the equal sign?
No, I don't think so.
Well, Spencer, I'm glad you were bold enough to ask the question. You don't think so. So this is what I would do if I was a student. I'd look back over here and look for the no more, and hopefully I put no more than. See, you would have made a mistake, Spencer,
Crap.
at least that part. So you go back to this. Luckily, Jeff gives you open book, open notes. No more than is a less than or equal to. So you include it. I'm not going to do this one in its entirety because of time, but I'll set it up. D, probability that X is no more than 2. So I start with 2, and then I add, okay, what's less than 2? 1. And one more, because you tend to forget this, 0. That means no heads, 0. So this one will require you to do it 3 times. Binomial PDF, binomial PDF, binomial PDF, and then add them all together. Okay. All right. Oh, Frank is still waiting. When you're late, you're late. Well, Frank, you're late, and I can't see. I forgot to make someone co-host, so you'll just have to listen to the recording, Frank, if you're still there with me. And now we are going to take one of your little baby quizzes, which I'm going to tell you what it's about before we're done for today. Give me a second here. I want to make sure it's you're ready for it. Daily quiz, you're at number 4. And I'm going to look at the quiz first. It's from, oops, gosh darn these things here. So I'm looking here, it's all from 5.4. Only 5.4. You guys can do this one. So what I'm going to do is I'm going to publish. And you guys tell me if you see it in your computer. I did publish. Thumbs up. Okay, 2 thumbs up. Okay. So I'll be here in the outside if you have any questions. There's only 5 problems, 2 points each. And otherwise, I'm here today between 2:30 and 3:30 if you need my help. And otherwise, I'll see you guys on Wednesday. So let's see, breakout rooms. Okay, it looks like I'll put you 4 to a room.
This is daily quiz 4, right? On Canvas.
It is daily quiz number 4. That's exactly
Perfect.
right.
Thank you.